Hello, friends. Welcome to Hydraulics and Hydraulic Machines course. We are discussing Unit 4, and Unit 4 is Hydraulic Turbines. Two lectures we have completed in this. In the first lecture, we introduced the hydraulic turbines, the components of a hydroelectric plant, and the classification of hydraulic turbines. Then, in the second lecture, we discussed on distinguish between impulse turbine and reaction turbine with examples, then distinguish between tangential flow turbine, radial flow turbine, axial flow turbine, and mixed flow turbine with examples. Then we discussed various efficiencies of a turbine and focusing on hydraulic efficiency, mechanical efficiency, volumetric efficiency, and overall efficiency. So this is the general part of the hydraulic turbines. In a way, it is an introduction to hydraulic turbines. So in this third lecture, let us discuss on specifically the Pelton turbine. So the description, the components, the sketch, and the characteristics of Pelton turbine. So that we will do in the present class. So before taking up straight, let us take it. What are the characteristics of Pelton turbine? So that I will take it. Pelton turbine. So first what I am taking it up is what are it the characteristics. Basically, Pelton turbine is an impulse turbine. Impulse turbine meaning already you know the whole energy is converted into kinetic energy or velocity head before the water strikes the runner. That is the very important point. The second point is it is a tangential flow turbine. It is a tangential flow turbine. The moment I say it is a tangential flow turbine, that means the water jet strikes the buckets which are surrounding the wheel at the tangent position. Tangentially, the water strikes it. And second thing, already I mentioned impulse turbine. Then it is a high head turbine. Generally, Pelton turbine is used when the head of water that is available in the reservoir is high. Pelton turbines are being used. That is the third point. And fourth point is it is a low specific speed turbine. So these are the important characteristics of the Pelton turbine. Then if I take next, what are the components of Pelton turbine? The components is there must be an arrangement to convert the total energy of water into kinetic energy. That is the first thing. So that component is called as nozzle and spear arrangement. Nozzle and spear arrangement. So this is basically this arrangement is mainly intended for converting the total energy into kinetic energy or velocity head. So this arrangement is meant for it. Then the important component of the turbine, any turbine is runner basically. And here and its buckets. Buckets means the vanes that are being fixed on the periphery of the wheel. That is second component. What is the most important third component is casing. If casing is not provided, then runner will be rotating just like that, and water, whatever that comes to onto the runner, it will be splashed everywhere, and it is directed all around 360 degrees rather than a focused way, and all that is going to be wasted only. Number one. Number two, if somebody goes nearer to the turbine, also accidents may occur. So casing is a must. Then fourth important component is braking jet. So the first and last, if you compare it, nozzle and spear arrangement is mainly intended for control of flow. Control of flow is by this actually. Suppose if we want to stop the turbine, automatically what we will do, we will be activating the nozzle and spear arrangement and close the inlet valve so that there will not be any flow onto the turbine. So, but the problem is even when there is no flow onto the runner, still the runner will be rotating at a very high speed and takes long time to stop actually. So that is why this braking jet is a jet which is sent in the opposite direction to the regular rotation of the runner, so that the runner will be brought to rest in no time. So these are the four important components. One after the other I will show to you. The first one, if I take it, nozzle and spear, both are there, nozzle and spear. Because why this is a very important component in Pelton turbine? Because the whole power, the entire, the definition of the Pelton turbine itself, conversion of the total energy into kinetic energy. So that is being achieved or attained by this arrangement. So what will happen here? What will be there is, for example, if you see, this is a rod actually, at the end of which will be having a spear, right? This is the first thing. And this rod actually, at the end we have a wheel actually. So this is the first thing. Then after this, the next one is naturally where this spear will get operated. So this spear will be operated in a nozzle. So this is the nozzle portion. Because why I am explaining, everything may be there in the textbook, but in the exam you need to write the entire figure. So this is the nozzle portion. Then through the nozzle portion, actually we have the penstock. From the penstock, from where the water will be coming out. So if I take it like this, so this is penstock, right? Right. This is the penstock actually. Now, actually, this. So the flow enters like this. This is the way how the flow enters, and this is the penstock, and at the penstock end we have to make it arrangement of this nozzle, and the other one is, this is called the spear. Sphere, nozzle and spear. So naturally, this arrangement, this nozzle and spear arrangement, this spear can be moved forward or backward. It can be moved forward or backward by rotating it at manually or by motor actually. Suppose if you are pushing this towards basically front end, if you are pushing it there, then this opening is closed, then there will be no flow coming out of it. If suppose you are pulling back, then naturally the nozzle will completely open and there will be enough water, which is the jet of water striking the runner. So this arrangement is the nozzle, and this is spear arrangement. Right. So this is the thing. So arrangement, this is the starting thing. So from the penstock, At the end of the penstock, we make nozzle arrangement and a spear. A spear will be moving in and out of the nozzle portion. So if you want to close it, we push it. If we want to allow water, we will pull back. That's how we operate this portion actually. The coming to the second point actually, what is the second point? Runner with buckets. Runner with buckets. The actually again it is a circular. The runner is nothing but a circular disc. A circular disc on the periphery of which on the periphery of which number of buckets are mounted. You also know that if the bucket shape is semicircular, automatically we get 100% efficiency. But in the case of Pelton turbine, it is not the semicircular thing, but it is a double semi-ellipsoidal cups. The shape of the bucket is double semi-ellipsoidal cups. Double means in each of the bucket there will be two cups actually. Each bucket, two cups. And they are their shape is the shape of this bucket. The bucket is double semi-ellipsoidal cups actually, which are mounted. And how that shape of that also I will show you basically both in plan and section I can show. Generally, if you see it, it appears like this. This is how it appears. But if I draw in plan how it looks like, if you take it, just this you have to draw actually in the exams. Please note, draw carefully along with me. Right? This is the one. And this is the central portion. Right? And from here, this is how it will be. Right? One more also you can draw. One more line. Right. After coming here, you can make it like this. It's a cut actually. So this central portion is called the total bucket is total like this actually. This is how it comes. This central portion which separates the cup is this is called as splitter, right? And this is one, this is the other. Both are basically semi ellipsoidal cups. At the end, there will be a small cut will be there. It's not just like continuous, but there will be cut like this. This is what we call it as. If I take the section of it, suppose if I take the section, Z is section, then if I see like this is how it appears. Right? So this is the portion. So this is the splitter. So naturally the jet strikes here and leaves like this. So the jet is getting deflected. If you see it, this is the deflected angle. So the section, if you see, it will appear like this. Jet strikes exactly at the splitter, it strikes and it moves away on both sides. That this is how it flows out. So this is second component, which we call it as the bucket actually. Coming to the third component, if you see it, casing. Casing means only a protection thing, just like a protection. It has no hydraulic function. No hydraulic function. It only prevents splashing of water. Splashing of water. Directs, it guides water to the exit. Right? These are the things. Generally, it is made of cast iron. Generally, it is made of cast iron or basically these fabricated steel plates. So this is what casing is. So only thing is it is a protection gear like actually to avoid splashing of water into the entire room actually. And fourth one is the braking jet. Braking jet. What will happen when a nozzle is completely closed? When nozzle is completely closed, how nozzle will be completely closed? By spear, by spear. Then naturally, what will happen? The amount of water, the amount of water striking the buckets is zero. Still, the runner will be revolving, and it takes a long time, and it takes long time to halt. Therefore, in order to bring the runner to halt, bring the runner to halt, a jet is a jet of water. That means jet of water is applied at the back of the veins. At the back of the veins. At the back of the veins means the meaning is in the opposite direction of the runner movement. Back of the veins. And this is called as braking jet. So these are the four components. Before closing the thing, I will show the figure, general figure actually showing everything. Just closely monitor and you also can draw along with me. Suppose this is the center, actually the center axis, which we call it as shaft. On the shaft, there will be runner, right? One more also we will draw so that, right. Then what we will do? Then next on these buckets will be there. like that buckets are there on the periphery. Now what will happen? The jet has to strike here, right? So what we will do, the nozzle and spear arrangement, if I see, so this is a nozzle, right? And the spear is, this is the spear, right? And this is the operating wheel of the spear, right? So this is the pen stock, right? This is how it is. Now what we will do, we will construct basically, for example, if you take it, all this arrangement is kept in a, with a casing actually. The casing, if I take it, right? This is the casing which we can have, right? So you see, number one, nozzle and spear arrangement is, this is penstock, you know, right? This is nozzle and spear, your first element. This is the second element, right? And this is how it rotates. And what is the third element is this casing, right? Then braking jet from somewhere here, actually, this braking jet will be operated like this. So here it will. So naturally, where it is rotating, basically the wheel is rotating like this. When once it strikes, the wheel is rotating like this. In the opposite direction, it falls. So this is the thing. This is the direction of rotation, right? Now braking jet is in the opposite direction. This is how it operates. So this is the fourth. So what are the components again? One more, nozzle and spear arrangement, runner and buckets. Third one is casing, and fourth one is braking jet. So this completes for us the first topic of the Pelton turbine. So you can practice this actually, the Pelton turbine, for the examination purpose also, components and all. And here I will stop the lecture here. And again, we will take it up the next portion. That means continuation of it. But what should be remembered in this is nozzle and spear is to control the flow, to convert the total energy of water into kinetic energy. Second one is the buckets of the Pelton turbine are double semi-ellipsoidal cups. So two cups are separated by a splitter, and each cup is semi-ellipsoidal cups actually. So that you should remember. So each bucket consists of basically two portions. Each bucket consists of two cups. One is one side semi-ellipsoidal, the other is other side. At the center, there will be a splitter which is separating these two semi-ellipsoidal cups. So that means if you see, this is how actually, if you see clearly, this is how the ellipsoidal cups will be basically like this. So even at the edge also, if you see, even our fingers thing, if you see, it is like just cutting basically the thing. So this is how it is. The portion will be like this actually. So the portion, if you see it, like our hands, put our hands to basically together. See our palm basically how it is. So that palm itself indicates the central portion is the splitter. This side double semi-ellipsoidal, other side semi-ellipsoidal. The finger is it will be less actually. So there it is cut like. So this portion is the Pelton turbine bucket shape. Casing has no hydraulic function except as a protecting gear, only to avoid splashing of water and to direct the water into the tail race. Braking jet is especially required because to bring the runner to halt, so that we will apply the flow in the opposite direction. That's all basically. I will stop this lecture here and we will take up the continuation part in the next lecture. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.